Problem solving at work. Problem solving is the ability to turn workplace chaos into clarity. This course is designed to help you do just that. You'll learn to transform setbacks into breakthroughs and challenges into opportunities. We'll start by exploring what problem solving really means in the context of the workplace. Then, we'll explain why it's an essential skill for engineers and scientists, especially in fast-paced, complex environments. You'll discover how adopting the right mindset, curious, objective, and resilient, can significantly improve your effectiveness. The centerpiece of the course is a structured 6-step process that leads from problem identification to final review. You'll explore the most common types of workplace problems, from technical glitches to strategic misalignments. We'll also walk through proven tools and frameworks that simplify complexity. You'll learn when to solve problems individually and when to involve a team. We conclude with a real-world case study and key takeaways to help you apply these concepts immediately. Course overview. In this course, we'll build a strong foundation in problem solving, an essential skill for any high-performance workplace. We begin by defining what problem solving actually means in a professional context. It's more than just finding answers. It's about thinking critically, navigating ambiguity, and creating sustainable solutions. Next, we'll explore why problem solving matters so much at work. From saving time and money to improving team collaboration and innovation, strong problem-solving capabilities drive results. We'll dive into the mindset needed for effective problem solving, curious, resilient, and open to feedback. Then we'll walk through a proven 6-step problem-solving process you can apply in almost any scenario. We'll identify common types of workplace problems so you can spot them early and respond with confidence. You'll get introduced to practical tools and frameworks to analyze and resolve challenges efficiently. We'll also compare individual versus team-based approaches, highlighting strengths and trade-offs of each. Plus, we'll look at common pitfalls to avoid and bring it all together with a real-life case study. Finally, we'll wrap up with key takeaways to reinforce learning and prepare you to apply these skills immediately. What is problem solving? Problem solving is a systematic process, starting with identifying a challenge and ending with implementing a well-chosen solution. It's not just about fixing what's broken, it's about understanding why something went wrong and how to improve it sustainably. At work, problems often show up in the form of operational inefficiencies like delays or unnecessary complexity. They can also include equipment malfunctions, such as faulty sensors or calibration drift. Communication breakdowns between team members often lead to misunderstandings and errors. Strategic challenges might involve shifting market dynamics or competitive threats. Quality issues, whether in products or processes, can jeopardize customer trust. And speaking of customers, dissatisfaction is a signal that something in your system or service is misaligned. The key is to systematically break down these problems, explore root causes, and move toward action. Effective problem solvers approach each issue with methodical curiosity and a commitment to real solutions, not just quick fixes. Why problem solving matters in the workplace. Effective problem solving leads to faster issue resolution and significantly improves productivity by reducing downtime. When problems are solved correctly the first time, recurring issues are prevented, leading to major cost savings. Good problem solvers also make smarter decisions under pressure, even when time is limited or stakes are high. Innovation is closely tied to this skill. Continuous improvement comes from identifying what's not working and finding better approaches. Another benefit is improved teamwork and communication. When problems are addressed openly and constructively, teams build trust and collaborate more effectively. Most importantly, those who consistently solve problems proactively become valued team members. They are seen not just as doers, but as contributors who help drive the organization forward. In today's fast-moving and technical environments, mastering problem-solving isn't just helpful. It's a strategic advantage that sets you apart as a leader and innovator. The problem-solving mindset. Great problem solvers consistently display 5 key qualities. First is curiosity. They ask how and why things work, or don't, and seek deeper understanding. Second is composure. Remaining calm under pressure allows for rational thinking and better decision-making. Third is objectivity. Strong problem solvers avoid finger-pointing and focus on facts, not assumptions. Fourth is persistence. When the first attempt doesn't work, they keep going, testing new ideas and approaches. Fifth is open-mindedness. They welcome a variety of viewpoints and don't settle for obvious or surface-level answers. Underlying all of this is a positive mindset. Rather than viewing problems as threats, they see them as learning opportunities and moments for innovation. This mindset transforms frustration into forward motion. Whether you're troubleshooting a process or improving team dynamics, these qualities lay the foundation for effective and lasting solutions. Adopting this mindset is the first step toward becoming a trusted problem solver. The 6-step problem-solving process. A structured approach reduces confusion and improves the odds of success. The 6-step process begins with identifying the problem clearly and specifically. Then, we analyze the root cause to understand why the problem is happening. Third, we generate a wide range of possible solutions, both creative and practical. Fourth, we evaluate those options carefully and select the best one based on feasibility, impact, and risk. Fifth, we implement the chosen solution with clear responsibilities and timelines. Finally, we review the outcome and reflect on lessons learned to drive continuous improvement. Each step builds on the one before it, creating a logical path from confusion to clarity. By following this framework, even the most complex problems can be broken down into manageable pieces. For scientists and engineers working in high-precision environments, this level of structure ensures that problem-solving is not reactive guesswork, but a reliable and repeatable method. Step 1. Identify the problem. The first step in solving any issue is to define it clearly. What exactly is going wrong? Avoid vague statements. Be specific about what's not working. Pinpoint the location and timing. Where and when does the problem occur? Then assess the impact, who or what is affected, and to what extent. Gathering facts and data early on helps you avoid jumping to conclusions. A poorly defined problem often leads to misguided solutions. Ask focused questions and document observations. For example, instead of saying the machine's broken, ask, what error code is being displayed, and during which operation cycle does it occur? A well-defined problem is already half solved because it points you toward the right area of investigation. Starting with clarity saves time, avoids wasted effort, and builds alignment among team members who need to work together on resolution. Step 2. Analyze the root cause. Once the problem is defined, the next step is to understand why it's happening. Don't just treat the symptoms. Look for the root cause. Start by asking why, repeatedly using the 5 whys technique. This helps you peel back the layers of the issue. Another tool is the fishbone diagram, also called the Ishikawa diagram. It organizes possible causes into categories like machines, methods, materials, environment, and people. For data-driven cases, a Pareto chart helps highlight the most frequent contributors to the problem. These analytical tools allow teams to shift from reactive to preventive thinking. It's critical to resist the temptation to jump to a solution too early. Without root cause analysis, you risk solving the wrong issue or only applying a short-term fix. By identifying the underlying factors, you position your team for a lasting solution that eliminates recurrence. Step 3. Generate possible solutions. Now it's time to explore how to solve the problem. Start by brainstorming as many ideas as possible, without judgment. Creativity is key. Encourage input from different perspectives. Some ideas may be quick fixes, others long-term structural changes. Use lateral thinking techniques to stretch beyond conventional answers. You might set a target, like generating 20 ideas, to keep the energy flowing. Remember, quantity leads to quality. The more options you generate, the more likely you'll find something innovative and effective. Possible solution types include technical fixes, process changes, training improvements, or collaboration strategies. Don't dismiss any ideas too early. Some of the best breakthroughs come from unexpected directions. The goal is to open up possibilities before narrowing down to one. This step helps ensure that you're not settling for the first idea that comes to mind, but rather selecting from a well-considered set of options. Step 4. Evaluate and select the best solution. With multiple options on the table, the next move is to evaluate them using clear criteria. Key factors include feasibility. Can we do it with current resources? Cost. What's the financial impact? Time. How long will it take? Impact. How much will it improve the situation? And risk. What are the potential downsides? For complex decisions, tools like decision matrices or scoring models can be helpful. These allow you to compare options side by side using weighted scores. Discussing the pros and cons with stakeholders is essential. They may offer insights or raise issues you hadn't considered. This also builds buy-in for the final decision. The best solution is the one that is not only technically sound, but also practical, timely, and supported by the people responsible for implementation. Objective comparison leads to confident choices that hold up under scrutiny. Step 5. Implement the solution. Once a solution is chosen, execution is everything. First, assign clear responsibilities. Who is doing what and by when? Without defined ownership, tasks can fall through the cracks. Next, allocate the necessary resources. That could mean budget, personnel, tools, or access to systems. Communicate the plan thoroughly with all stakeholders. Everyone involved should understand the goals, steps, and expected outcomes. As implementation begins, monitor progress closely. Are things on track? Are issues being reported and addressed in real time? Be ready to adjust based on initial feedback. Few solutions go perfectly the first time. The goal is to maintain momentum and correct course if needed. Strong follow-through, frequent updates, and active listening can make the difference between a solution that works and one that stalls. Implementation isn't just about doing, it's about leading others toward a shared result. Step 6. Review and reflect. After the solution has been implemented, it's time to evaluate the outcome. Ask, did the solution work as intended? Did it address the root cause and improve the situation? Next, identify key learnings. What worked well? What could have gone better? This reflection step isn't just about critique, it's about building future capability. Documenting lessons learned helps avoid repeating the same mistakes and strengthens the organization's overall problem-solving maturity. If changes to procedures or standards are needed, update them now so the improvements are sustained. This final step closes the loop and turns a single problem-solving event into long-term growth. In high-tech environments, where precision and reliability are vital, post-analysis and reflection are what transform good teams into high-performing ones. Structured review prevents recurrence and fuels continuous improvement across teams and systems. Common workplace problem types. Problems at work come in many forms, but they typically fall into 4 categories. Technical problems include machine breakdowns, software bugs, and system inefficiencies. These often require engineering or IT support, along with root cause analysis. Process problems are about flow, bottlenecks, delays, or inconsistent quality. These benefit from Lean and Six Sigma techniques. People problems involve human dynamics, conflicts, misunderstandings, or low morale. Solving these requires emotional intelligence, active listening, and often mediation. Strategic problems are higher-level challenges like shifts in market conditions, declining revenue, or barriers to growth. These require data analysis, scenario planning, and alignment among leadership. Understanding what type of problem you're facing helps you choose the right approach, tools, and collaborators. It also clarifies where your technical skills intersect with interpersonal and strategic thinking, an essential combination for success in modern workplaces. Problem-solving tools and frameworks. A range of structured tools and frameworks are available to support your problem-solving efforts. The 5 Whys method helps dig deep by repeatedly asking why an issue occurred, getting closer to the root cause with each answer. The fishbone diagram, or Ishikawa diagram, visually maps possible causes into categories such as materials, methods, machines, and manpower. PDCA, plan, do, check, act, is a cycle that supports continuous improvement through experimentation and iteration. SWOT analysis helps assess strengths, weaknesses, opportunities, and threats, especially in strategic planning. DMAIC, used in Six Sigma, stands for define, measure, analyze, improve, and control, ideal for quality-driven problem-solving. Brainstorming and Scamper are creative techniques that encourage divergent thinking and idea generation. While tools don't solve problems by themselves, they add structure, clarity, and direction to your efforts. Used correctly, they help transform complex situations into actionable insights. Individual versus team problem solving. Problem solving can be done solo or in teams, and each approach has its strengths. Individuals often move faster and make decisions with greater focus. There's clarity and ownership and the ability to act independently, great for urgent or tactical problems. But teams bring something equally important: diverse perspectives. They offer cross-functional insights and collective expertise. When multiple viewpoints are involved, the solution is often more robust. Team-based problem-solving also builds broader buy-in. People are more committed to solutions they helped create. The choice between individual and team approaches depends on the problem. For urgent, contained issues, a solo approach works. For complex, strategic, or systemic challenges, teamwork is essential. The best problem solvers know when to act alone and when to bring others in. Balancing speed and collaboration is key to effective problem resolution. Avoiding common pitfalls. Problem solving can go wrong in predictable ways. One common pitfall is jumping to conclusions. It's tempting to act quickly, but diagnosing before prescribing ensures you solve the real issue, not just a symptom. Another trap is over-engineering, adding unnecessary complexity when a simple solution would suffice. Keep it lean and focused. Avoiding conflict is another risk. Tough conversations are part of the process. Avoiding them only delays resolution. Blame culture is also toxic. Focus on fixing the process, not pointing fingers. Lastly, beware of analysis paralysis, spending so much time analyzing that you never act. Perfect solutions rarely exist, so progress is more valuable than perfection. The best outcomes come from thoughtful yet decisive action. Recognizing these pitfalls early helps you stay agile, focused, and solution-oriented, traits that are highly valued in any technical workplace. Case study: root cause in semiconductor manufacturing. Let's walk through a real-world example from semiconductor manufacturing. A production line experienced an unexpected 8% drop in wafer yield. Using a structured problem-solving approach, the team pinpointed the issue to line 3. They analyzed system logs and conducted a 5 Whys session, eventually discovering a calibration drift in an atomic layer deposition (ALD) tool. This misalignment was the root cause. The team generated multiple solutions: recalibration, sensor replacement, and introducing preventive maintenance. They selected a dual solution: recalibrate the tool and replace the sensors, along with a long-term PM plan. Implementation was completed overnight with support from engineering and maintenance. Within 48 hours, yields were fully restored. To prevent recurrence, a preventive checklist was added to the standard operating procedures. This case illustrates the power of structured thinking to save time, reduce costs, and protect product quality and organizational reputation. Problem solving is a superpower. Structured problem solving isn't just a technical skill, it's a superpower. It transforms confusion into clarity and setbacks into opportunities. In today's fast-moving, high-tech environments, every role and level benefits from strong problem-solving capabilities. Engineers who solve problems proactively stand out. They shift from reactive firefighting to proactive leadership. They navigate uncertainty and complexity with confidence and strategic thinking. They don't just fix what's broken, they build better systems. Over time, these habits drive continuous improvement and fuel innovation. They also earn trust, build influence, and contribute directly to growth. Whether you're resolving a machine error, untangling a communication issue, or improving product quality, problem-solving is the foundation. The message is simple. Don't wait for others to fix it. Be the one who figures it out. The mindset, process, and tools you've learned in this course are your launchpad to becoming a high-impact contributor in any technical field.